Using a table to find this limit, I'm going to substitute values close to -3 from the left and from the right. -4 is close on the left and -2 is close on the right. Then I substitute some numbers even closer to -3 on the left and the right. I'm looking for a pattern, and as I substituted in numbers closer and closer to -3 from the right, I'm heading to -3,999. But as I substitute numbers getting close to -3 from the left, I'm getting close to 4,001. Well, we're not coming into the same number. From the left side, we're going really high, 4,001. But from the right side, we're getting really, really low, -3,999. So the limit does not exist. We are not getting closer and closer to the same value. I want to just point out that if you substitute a -3, you would get an error. And it's a coincidence in this case that just substituting -3 says, oh, the limit doesn't exist. You cannot blindly substitute the value and think you're going to get the answer to the limit. Let's look at the picture just to show this point. If I were to substitute in -1 into this exact same function, I would get an error, but the limit would exist because we would have an intended height from the left and the right. If I substitute -3 into this function, I get an error, which then would be does not exist because we have an asymptote. So please remember that blindly substituting the number into the function will not get you the limit. Hopefully by now I have said enough times it is not okay for you to blindly substitute the value you're getting close to into the function and think that you are always going to get the answer to the limit. But there is a shortcut. Sometimes you can do that. You can do that when you know that you do not have any domain issues. You're not dividing by 0. You're not taking the square root of an even number. You're not taking the logarithm of a negative number or 0. So I want to show you an example where we would have been able to just substitute in 3. But let's start with the table. I start picking numbers close to 3 from the left, so 2 is close to 3 on the left, 2.5 even closer, 2.9999 even closer. Looks like we're heading to a value of 9. Let's try choosing numbers close to 3 from the right. Put in 4, put in 3.5, numbers even closer to 3 from the right. 3.0001, and I get 9.0006. Again, looks like we're heading to a height of 9. Using the tables, we would have gotten that we are heading to 9. But if I just substitute in 3, this time I get out 9. And it happens that in this case, that the limit as x approaches 3 of x squared does equal the function evaluated at 3. But that's because the curve x squared is smooth. There's no breaks, no holes, no asymptotes. So anytime we know that the function that we're dealing with is smooth at that x value, you can just substitute the number in and skip the tables. Look here, coming in from the left, heading to a height of 9, coming in from the right, heading to a height of 9, but the actual value, 3, at x equals 3 is 3, 9. So if you know that the curve is smooth at the x value, just substitute it in and you may use the shortcut. So some of you are getting nervous. You're like, how much of the pre-calc do I remember? Is it smooth there? I'm sure you know a parabola is, but there might be some other functions that you're doubting yourself. That's okay. Another kind of shortcut along those lines is as long as you're not dealing with a piecewise function and you substitute in the number, then if you get an answer, you get a value, a number, then that is going to be your answer. But if you get an error message, then you've got to use the table, because an error message means there was a hole or an asymptote, and limits exist at holes, and the table is going to take you to the intended height from the left and the right. But an asymptote is not, the limit does not exist. So we would still make a table to determine that as I pick numbers closer and closer to the x you're approaching, that those values are not getting anywhere closer to one another. So the limit doesn't exist. Here's just a quick example of that. So here I have an absolute value in this one. If I just substitute in -1, I get out 1. I'm going to skip the entire table. I'm like, the answer is 1. If I take a look at the graph, just so you can kind of see what's happening at -1, see how if I start picking numbers close to -1 from the right, I'm going to keep getting answers 1, 1, 1, 1. And if I pick numbers close to -1 from the left, I'm going to keep getting answers 1, 1, 1, 1. And that is because coming into -1 from the right and the left, we're heading to a height of 1. If I were to just substitute -3 right now, I'm going to end up with 0 divided by 0. Danger. 0 divided by 0 is not 0. That is an error message in indeterminate form. So I would have to use the table. I've done so many examples, I'm not going to make a table again, but if I pick numbers close to -3 from the right and the left, I'm going to keep getting out, as I pick numbers close to -3 from the left, I'm going to get out the answer -1 over and over and over again. If I pick numbers close to -3 from the right, I'm going to keep getting out 1, 1, 1, 1. Those are not numbers that are getting closer and closer to each other, so the limit would not exist.
Tonight in your homework, you're going to be finding the limits using a table. As long as you're not dealing with a piecewise function, if you notice that the shortcut is available, you are welcome to use the shortcut and skip making the table. To use the shortcut, you would begin each problem by substituting in the number that x is getting close to. And if you get out a value rather than an error or 0 divided by 0, then that value is the answer to the limit. If you substitute in the number that x is getting close to and you get 0 over 0 or an error message, then that means that you're going to need to make a table and forego the shortcut.